Welcome back, everyone. And today we're going to continue with 16b. So we're going to talk about the normal distribution with approximately 68%, 95%, and 99.7%, the differently of the graphs. And so if you have a 68% normal distribution, we call that we're seeing the one standard deviation of mean. And if you approximate for 95%, we talk about the two standard deviation of the mean, and almost the all 99.7% within three standard deviation of mean. So this is a different with the graphs. So if you say the numbers of standard deviation with the mean, you can say you name with the number lines. So -1 to 1 is 68% of your whole graphs, and that was your mean of the one standard deviation. And if you have a 2 to -2, and that's 95, so we call that a two standard deviation of mean. And 99.7, so we're going to 3, so which is all under the curve graphs. And that's the 3 standard deviation from -3 to 3. So now we're gonna using our knowledge to do the graphs. So the experience show the score, which is obtained to the commonly IQ test, can be assumed the normal distribute with your mean is 100 and standard deviation is 15. So approximately the percentage of the distribution within one or two or three standard deviation of mean. So first thing first, we could have a look the first one. So since we have since the mean is 100, which is mean is 100, standard deviation is 15. So we're gonna graph the score for the 68% of the test. So we could approximately with the 68%. So we can have a look. So the graph of it looks like, if I start from 40, so maybe start like the lowest with like 40, 50, 60, 70, 80, 90, 20, 100, 110, 120, 130, and 140. So the lowest point, if I test the Google the question, you can say maybe the lowest one was like a 55 around. So which is we can start from here as our starting point, and the graph will be looks like the highest one maybe the 100, which is around this one. So this is maybe the main distributions, and then drop on to 140. So the graph will be looks like and distribution from here to here to here to here to here. Yep, that's it. Yeah, so that's non-stop, so you never know what's going on with the normal distribution looks like. So what we know is standard deviation is 15, and then the mean is 100. So we can separate them to say from a score from percentage, which is using a symmetry distribution to say the total area of under the curve is 100%. So the question can be is, if I from 100 is 0 and 110 is 1, 2, 3, and 4, and -1, -2, -3, and -4. So if I say 68%, I can say it's around like 85% to 115% is approximately 68% of the distribution. And for 95%, approximately from maybe 70 to 130. That's around. So which is 70 to 130. That was the 95% of distribution. 99%, 99.7%, which is around like 55 to 140. So 55 to 140 is 99.7%. Yeah. So that's the symmetry graph looks like. Or if you are not sure how to do that, so we could using our general graphs, which is a function of fx equal to 1 over the standard deviation times square root of 2 pi and times e to the negative half x minus the mean divided by standard deviation and square. So we're using that to find your anti-differentiations equal to 68%, 95%, or 99.7%. Okay. So yeah, this is a graph we need to know. Yeah. Hopefully that makes sense. Yeah. So you just substitution your mean and your standard deviation into this function to find your anti-differentiation, and then to figure this out. 68, 95, and 99.7% looks like. Yeah. So once you get in this one to understand this, another thing I want you guys to remember, standard value, which is equal to so standard value will be the x minus the mean divided by standard deviation. I will show you how we're gonna find the standard value is. So standard value will be data value minus the mean of the normal curves divided by standard deviation of normal curve, which is this one. Yep, and here is the examples for you guys to understand what's the positive z value and negative z value. Yep. So another examples, which is we're gonna find 95% of the standard deviation. As I said, you could be between the 70 to 130, which is the true standard deviation, but what percentage of the score the mean more than 2 standard deviation above the mean? So that means if you had a graph, and your standard deviation will looks like that. Damn it, standard deviation will look like that. So the 95%, which is examples 95% of the curves here, which is this side is 2.5% and this side is 2.5%. So because the below 70, so which is so below 70 and above 130 is 2.5% of the area, and the score greater than the 130 is on the test, it will be in the top 2.5% of the group. But if you're below the 70, will be that means you will be the another side of the below the 70%. Yep, you'll be the bottom 2.5%. Yeah, hopefully that makes sense. Let's keep going with the 16C in the next lady. So we're gonna using the CAS calculator to calculate our z values, and hopefully that makes sense. I'll see you guys